we want to talk about is the light wave. Okay, transverse light wave. So, light wave we have three different types. So we have a parallel beam, okay, going straight line. A diverging beam is going far away from the center, and converging beam means go towards center. Okay, so parallel, diverging, and converging beams. Okay, so we actually have two types of lenses. Is one is the concave lens and one is the convex lens. Okay, you can see over here a convex lens. When it's come from far away, okay, the convex lens will focus all the light ray towards the middle over here. So this is a focal point. Okay, you can say that when light parallel from the principal axis, this is a principal axis. Light from parallel to the principal axis going through the lenses, the convex lens, focus to a single point. We call it a focus point. Okay, then if this one is I move it over here better. So this one I move it over here. If the convex one, concave one, so the concave one when the parallel going away, it will also have dotted line over here, but it's actually going away. I think I draw opposite already. So it's supposed to be going here. Okay. Okay, it's actually going further away. Okay, so this is a concave lens. Okay, but usually question don't just stop over here. You usually start from your eye. Okay, so what type of spectacles we need to wear when we are in short sightedness or long sightedness? Okay, the important part is called sightedness. Sightedness means the ability to see lah. So short sightedness is ability to see short distance, and long sightedness is ability to see long distance. Okay, but this is your eye. So long sightedness we can see, for example, if the light travel from far away and it can focus to a single point over here. Okay, so we call it long sightedness. But when the object is near, it's actually because it's so close, it focus way behind the retina. So you can see the image quite blurry. So what happened we need to do? So what do you need to do? So we need to have a convex lens to focus the light in the parts in front. So we have convex lens, so you focus and you continue focus to reach here. So long sightedness we wear convex lens, and short sightedness we call wear concave lens. Okay, to see clearly. Okay, so it's like this lah. Okay, other than that we have also learned about magnification. So how we know it's going bigger or smaller? So m equals magnification equals the size of the image lah. So the image and the size of the object. Okay, so the object is, so if the object is 4 cm and the image is 2 cm, then you just put it in lah, and you can get the answer already lor. Magnified or not magnified. Other than that is also have dispersion of light, is where if this is a triangle, okay, we know that the different type of wavelength you bend the light differently. So for example, it's bent like this and going like this and going further away and going further away like this. Okay, so these are two different not two different lah, just usually mean like this. Okay, how we should know it bend, where it should bend? Okay, for example, this we can know like this. Okay, so we draw, this one will be the line, okay, of the normal. So we can see what's move further away is the wavelength that are bigger. So red have longer wavelength, so it will going further away with red lah. And the purple one will be much closer, violet, because of the different type of wavelength. This one's wavelength is bigger, this one's wavelength is smaller. Okay, and this one again you can draw like this, see, and it's go further away lah, or closer to it. Okay, so this just how you can know separate from red to violet. Okay, so longer wavelength, less diffraction, shorter wavelength, This one a bit different. We know that just now what we learned is like longer wavelength have more diffraction, but in this part, not in this case. Why? Okay, you can think it's like this lah. I don't want to go into detail that much, but okay, just simple explanation will do. Okay, for example, this is a triangle. When the red passes through, it going just like half, maybe three quarters of a wavelength. But when it's a blue light, it's actually maybe three wavelength. So the ones that in red, they only undergo 3/2 wavelength. Means that it be inside the prism for a short period of time. But the blue one is in the prism a long period of time. That is why it will have a more diffraction. Not that because of the wavelength thing, but because of the because of the wavelength thing lah, but because of the time it spent inside the prism. That's the main difference. Okay, so that's the main difference why we say that like the longer wavelength have less diffraction in this case, only in this case. But usually when we talk about the previous one, we talk about the diffraction towards a whole. For example, towards a whole, a longer wavelength it will diffract more. Why? Because the wave is not blocking to one another, so it will diffract more. But when it's closer together, it's actually pushing the wave to be going forwards, so it will diffract less because I'm pushing the wave going forwards. So that's the reason why shorter wavelength have shorter diffraction in this scenario. But when in this scenario, it's totally different already lah. So it's, you need to know what is the case in order to know the diffraction thing. Okay, so sometimes they will use a topic outside about like optical wave, optical fiber. So what is used about optical fiber? So for optical fiber for telecommunication, communication, and sometimes we use for medical endoscope because it will always undergo total internal reflection. Okay, total internal reflection. That's why you can see the image from inside. Okay, the last thing what we will learn is about this. So how we draw the image of a lens. Okay, I think this is too big, so I'll give a smaller one, maybe like this. Okay, so I give one, this one is the 1 2 3 4 1 2 3 4 5 1 2 3 4 5 here, 1 2 3 4 5 the other one, and the other one is over here. Okay, so this is F, this is 2F, this is F, this is 2F. Okay, so how we usually draw the line is it start from infinity. If it start from infinity, the image very big, very far away, it will go through the F. Okay, it will go through F. For example, we go through F. Okay, then it will go through the other one is go through the middle. Okay, I mean it will be parallel lah. Okay, then it will actually continue, and this one will be going towards like this. So this one will be the image. Okay, something like that lah. My drawing is not that good lah. It's actually going to be land. I think it's going to be land. Oops, sorry. It will land much further away lah. Maybe like here lah. Okay, but because of my drawing is not that good, so I can draw nicely lah. But usually it's mean like this lah. This is middle. I can draw the middle line. Okay, so usually like this. So when it's important how to draw this line, there's two lines. The first line will be the one that pass through, for example, is over here, the one that pass through F, and one straight line pass through F and going to middle, and the other one is just passing through the middle line, and this one will be your image lah. Okay, you can see always the difference. So over here will be real image, and real, and this one will be virtual. Okay, upright, inverter, diminish, enlarge, and that one you can know by yourself already lah. Other than that, you can know by yourself already. So only these two lines. Sometimes we can draw another one, is draw this line. You can draw this line. It's actually the same line going through, then going through F. Okay, so this one is going through F, then going straight, and this one is going straight, then going through F. Okay, going straight lah. This must be a straight line and this one must be a straight line Okay, then this one too is actually the same thing lah. So how you draw it is okay. The main one people want to know is about if the object is over here f, or maybe shorter than f lah. So shorter f sure is going to be like this, going straight, okay, then going through f, then this one going through the middle, so the object image will form over here. So you need to draw the arrow also lah, how the arrow propagate is very important. This is your eye lah. Okay, so you can see this one is the virtual image because the image forms over here. Okay, this one is usually a magnifying glass also, because when you see your eye small object, you can see big things ma. Okay, when you say magnifying glass, inside a magnifying glass you can see the object become bigger. So this is actually used for magnifying lah. So this is how it usually the case. So if not, if it's it's over here, for example, here is usually just go through middle, and this one will go through middle, and this one going to infinity lah. Okay, go through infinity. So this one is the arrow also. So this one going through infinity. I will draw like this. Okay, going through infinity. Okay, the image will fall very far lah. Okay, so this is your eye again. So this one will be upright, virtual, and magnified also. It's the same thing lah. So this is we finished the part for light. Okay, for light it's until this part only. Okay.